Hello, good morning. So is the slide visible? Am I audible? Anyone? Please respond.
Yes, sir.
Okay. So now let's start. Up to the last class, we have discussed about software project management and process management. Today we'll look at quality management. So actually, we are having 2 classes left today and tomorrow. We will take a little bit more time on today and tomorrow to finish up this quality management portion. So please do not leave patience. Though today is actually most of the easiest class. We'll go only point wise. Details are available in the book. Slides also I will share. So you will look at that. So before going to that, let us see tomorrow what will the feasible time to take, because tomorrow 4:15 I have some work. I may have to go to my village. So tomorrow, anybody else? Let's see. 11 o'clock will be okay tomorrow, or is there any class? Please respond. Anybody? MTech, dual degree, or BTech? Tomorrow 11 o'clock. Any class?
We have class tomorrow. MTech.
MTech which subject?
Software engineering. We have advanced software engineering class.
Of Julistor Mahapatra.
Yes, sir.
Okay. So any other time free tomorrow morning? Or
also we have classes.
Sorry?
Morning also we have classes.
Okay. What is about 1:15? 15?
So 1:15 we have extra classes of advanced software.
Students, any problem at 1:15?
Yes, sir. We have extra class at 1:15.
Which subject?
MTech, advanced software engineering. We will be having 2 classes tomorrow for advanced software engineering.
Who will take?
Sir, advanced software engineering.
One is
Judith.
software. He will take at 11 o'clock. Again at 1:15.
Yes, sir. Extra class at 1:15. Yeah.
Yes, so he will take one at 1:15. Acha. Okay, then 2:15. 2:15 any class? BTech students? Acha, the dual degree students? Okay, then we can try to take at 2:15. Okay, so if I assume that nobody is having any problem because no what complaint so far. So tomorrow we'll take at 2:15 instead of 4:15, because 4:15 I have to leave to my village. So we'll because the communication due to communication problem. Even if today I'm at Bhubaneswar somehow managing, and tomorrow we'll take at 2:15. Okay. So now let's and tomorrow we'll try to do the quiz. So either immediately before the class or immediately after the class we will do the quiz. So please prepare accordingly. Let's see. If it is successful, then that's okay. Otherwise, when you will return to the campus, we have to do physically. Okay. So as I have already told you, today we'll discuss about the quality management. Let's see the fundamentals of software quality management. So let's see first what is software quality, and then we'll go for software quality management. So if you'll see the traditional definition of quality, you'll see that it is defined as fitness of purpose. That means you'll say a product as a quality product if it exactly does the thing what the user wants it to do. So if a product it does the same thing what exactly the user wants it to do, then we say that yes, it is the fitness of purpose, for which purpose it was what design it is working that thing. So we say that it is a quality product. Fitness of purpose for software products. So this is actually mainly, see, if it is a hardware product, no problem, this definition will work. It will suffice. That a quality product does exactly what the users want it to do. But let's see in software products, what does it mean by fitness of purpose? In case of software products, fitness of purpose means satisfaction of the requirements as specified in the SRS document. In the SRS document, what you have specified, whether after developing the software product, whether it is satisfying all the requirements as mentioned in the SRS document or not. This is what is meant by fitness of purpose for the software products. So this definition that I have told, that fitness of purpose in relation with the traditional definition quality. So respect to definition of quality for many hardware products, you can say, like a car, table fan, food mixer, micro oven, refrigerator, etc. But this definition of this fitness of purpose, it may not be satisfactory for software products. Let's see why. Why it is not satisfactory for software products? Let's take a small example. Suppose you are developing a software product. It is functionally correct. Functionally correct means it performs all the functions as you have specified in the SRS document. For example, you have taken library information system. The functionalities you have mentioned in the SRS document are issue book, return book, reserve book, check book, check availability of book, add member, delete member, add books, delete books, compute file, etc. It is doing everything else. When you are developing the software, it is developing everything else. Now, but it is a small problem. It is having a user interface which is not usable. People are not preferring very nasty user interface. It is unusable. Can we call it a software? It is a good or it is a quality software product? Certainly not. Even if it satisfies all the functions as mentioned in the SRS document, but its interface is so ugly. It is unusable by almost all the unusable by almost all of the users. So we cannot say that even if it satisfies all the functions, since it is having a very poor GUI, so we cannot call it as a quality product. Let's quickly take another example. Suppose you have developed a software product which does everything that user wants, but it is an almost incomprehensible and unmaintainable code, a very traditional code, legacy code, and that code is unmaintainable, it is incomprehensible. Can we call it as a quality product? Certainly not. It is not a quality product. So in this way, we have seen this traditional definition of quality. It may not be applicable suitably to the software products. Okay. Then let's see what is the modern view of quality for software products. So several quality factors are associated with a software product. If we consider software product, several quality factors are there. What could be the quality factors? Such as correctness, reliability, efficiency, portability, usability, reusability, maintainability, security, and so on. These are some of the quality factors which are associated with a software product. And yes, please. Any problem? Okay. So now you see these are very easy definitions. You know what is correctness, what is reliability, what is portability, what is usability. No need to explain. So these factors need to be satisfied. If a software is fully correct, it is fully reliable, it is portable, easily portable from one system to another system. It's usable. That means a novice user can use it perfectly, as well as an experienced user, he can use it with a very short time or like that. Many of the components can be reusable. It can be easily maintainable. It have good security features. So if all those things are satisfied, if all those factors are satisfied, then we say that yes, the software product is a quality product. So these definitions of correctness, reliability, etc., it's easy. I have given in the next slides, but these are quite easy. You please read yourself. What is correctness? A software product is correct if the different requirements as you have specified in the SRS document, they have been correctly implemented. All the functional requirements as you have mentioned in the SRS document, they have been correctly implemented. And similarly, the results must be accurate. Then you will say that a software product is correct. Similarly, other definitions I have written, these are easy: portability, reusability, usability, etc., maintainability. These are easy definitions. Please read yourself. No problem at all. Now we'll go to our stepwise approach that we have discussed. What are the stepwise approach for project management? These are the things, these steps we have seen already. We have discussed in the earlier classes. Now let's see this quality. It will apply to which stage? It will, in fact, this quality, if you'll see, it is applicable for almost all of the steps starting from 1 to 10. Okay, but so as I have already told you, quality will be of an important concern at all stages of project planning and execution, but it will be particular interest at the following points in the stepwise framework. So in this case, let's see, it is applicable for all the steps, but particularly if you look at, it is particularly applicable for the following steps. Let's see. It is applicable at step 1. What is step 1? You have already known. Step 1 is identify project objectives. That time also we have to give emphasis on quality. Then step 2, identify the project infrastructure. That also we have to look at this. We have to give emphasis on software quality, like this. So similarly at step 3, step 4, step 8, at those process we have to give, at these steps we have to give special emphasis on software quality. Okay. Now let's see what is the importance of software quality. Why you are giving so much importance to software quality? These are some of the reasons why you are giving what importance to software quality. 1, increasing criticality of software. Nowadays, the criticality of the software is increasing. There are several softwares which are very much critical. I have already told you those critical softwares are known as what? Safety critical systems. Examples are where the software where a single fault, minor fault, will lead to loss of 100 lives or loss of crores of rupees. Very good examples of safety critical systems. And examples are, you are developing a software for navigating an aeroplane or a rocket. That's an example of safety critical system. For the banking system, where a small mistake can lead to transfer of crores of rupees to another account. So that is another example of safety critical systems. So in this case of these safety critical systems, the software quality is highly important. So these are some of the reasons. These are the importance of software quality. Number 1 is due to increasing criticality of software. For example, when a software is increasingly, being used in systems that can threaten or support human life and well-being. Example I have already told you, like developing a software for navigation of aeroplanes or rockets or expert systems, or software for medical systems and banking systems, etc. These are criticality or software systems having more criticality. We call them as safety critical systems. For that, we must ensure that the quality should be almost 99.9%, because minor error, minor problem will lead to loss of hundreds of lives or crores of rupees. Next reason is the intangibility of software. In case of hardware, no problem. You can at least able to see the progress of the hardware. You can see it. So at least if you can see it, then you can see that whether it is good quality or bad quality. But in case of software, it is not visible. It is intangible. So yes, so this intangibility of software, due to this, it is very much difficult for observers to judge the quality of software development, especially during its early stages. If you are in the design stage or in the coding stage, very much difficult to see it. What is the progress? How you can judge? So due to the intangibility of software, that's why the software quality is also very important. Otherwise, at the end, you will get a very poor quality software. So these are some of the importance of software quality. Few more may be there. You can see yourself, like project control concerns. You know, the errors, they accumulate to each stage. Take the example. If you are taking this, that means if the error in one stage somehow you have overlooked, it will propagate, it will creep into the next phase, and you have to put more effort. You know, this phase containment of errors. Phase containment of errors means try to detect the errors in the same phase or as early as possible. Don't allow it to move it to the next phase. If it will move to the next phase, you have to put more effort. For example, if a requirement analysis error, it creeps into design, you have to put more effort to correct it. Similarly, if a design error, it is passed to coding and then is passed to testing, then you have to put huge amount of error to correct those design errors which you are detecting at the testing phase. So in this way, you should try to detect the errors in the same phase as much as possible. Don't try to allow it to go to the next. This is known as what? Phase containment of errors. You might have read in advanced software engineering. Errors become more expensive to remove later they are found, isn't it? If you are finding the errors in a later stage, for example, analysis error, you find a design phase, or design error, you find out the testing phase. You have to put much more effort to correct them. They become more expensive. It is also difficult to control the error removal process. The testing process will be difficult. So if errors they accumulate with each stage, then what will happen? They will become more expensive to remove later on, and it will also become difficult to control the error removal process. So this is how this is the importance of software quality. If you will not make your software of high quality, then these errors, they will just creep into the next stages, and you have to put much more effort to remove them. It will be difficult to control the error removal process. So these are some of the reasons we have seen the importance of software quality. Now let's see quickly about quality specifications. Where there is a specific need for a quality, produce a quality specification. Okay, you see the cases for the software. Now here there is a specific need for a quality, you have to produce a quality specification. And this quality specification should contain what? This quality specification should contain the definition or the description of the quality, as I have already given. For the modern software products, what should be the definition, what parameters, what factors they affect the software quality. You have to write down the definition or description of the quality. Then you have to measure the scale. You have to mention the scale. How you will measure this quality scale? The unit of measurement, for example, number of errors maximum allowed. Say 1% error should be allowed, like this. If it is more than that, we say that it's not of a good quality product. So the unit of measurement. Or in terms of failure, the software might fail maximum 1 in 100 times. So like that, you have to give the unit of measurement. This is the scale, the unit of measurement. Similarly, you have to mention the test, the practical test of extent of quality. What kind of practical test you will conduct? Okay, practical test of extent of quality. Minimally acceptable, lowest acceptable value if you compensated for by higher quality level elsewhere. So what is the minimally acceptable things? The lowest acceptable value. That means, as I have given you, say, okay, 1% error we can accept. We cannot accept more than 1% error. So the minimal accepted value we have to mention, the lowest acceptable value if compensated for by higher quality level software. Target range, what are the desirable value? This is the minimal acceptable, like 1%. The target range, the desirable value should be 0.5%, like that. Those 0.5% errors should be desirable, but minimum, okay, we may go for 1% of the errors. Then now value that currently applies. Currently, what are the errors those are available that you find in your software? So value that currently applies. So like that, in a quality specification, these parameters should be mentioned. So let's see what are the standards available for quality. Many standards are there. Here we'll see ISO standards. First, we'll see the development life cycles for this quality. A development life cycle like ISO 12207 indicates the sequence of processes that will produce the software deliverable and intermediate products that will pass between the processes. So these are the sequence of processes those will be required to get a quality product. First, what you have to do, you have to elicit the requirements. Elicit means collect, gather the requirements. Then you will get the requirements. So after this, requirements you can collect what you can design the software. Then you have to design the software architecture, and from the software architecture, what you can do, you can go for this coding and testing. Then you will get the tested code. So your input is the requirements, isn't it? Then final deliverable, final output is the tested code, fully working code. And these products are requirement, software architecture, these are the intermediate products. Okay. And even it is possible nowadays from the requirements also you can get the code. For GL documents are there, for GL languages from where you can get the code from the what requirements directly. So this is a development life cycle. So you can follow ISO standards for this software development life cycle. These things we have already discussed, you can read yourself. Now let's quickly look at the ISO standards. The ISO 9000 series of standards, they establish the requirements for quality management systems for the creation, supply of all types of goods and services. Okay. So ISO having a series of standards. We call them ISO 9000 series of standards. The ISO 9000 series of standards, they establish requirements for quality management systems for the creation or supply of all types of goods and services. Now let's see about software quality management system. Popularly it is called as quality management system or quality system. It is defined as the principal methodology which are used by different organizations to ensure that the products have desired quality. So basically quality management system means, or quality system means, the principal methodology that will be used by the organizations to ensure that the products, they have desired quality, the intended quality. A quality system consists of the following two important things: the managerial structure and then the individual responsibilities. So a quality system consists of two important things. What should be the managerial structure, or what should be the structure of the managerial structure, and then the individual responsibilities. The responsibility of the organization as a whole also. Okay. So the also here we have seen what will the individual responsibilities. Also we have to see, we have to know what should be the responsibility of the organization as a whole. That also affects a lot to the quality of the product. Every quality conscious organization, they have an independent quality department. You go to any software organization, or even if any manufacturing organization, you go to Rourkela Steel Plant, wherever. So they have a what a department called as a quality department, that is an independent quality department. So what is the job, what is the function of that quality department? It performs several quality system activities. Okay, this department called as the quality department, it performs several quality system activities. This independent quality department, it needs support of the top management. Without support at the high level in a company, many employees may not take the quality system seriously. So if there will not be pressure from the top level management, without support at a high level in the high level management in a company, many employees, many workers, they may not take the quality system seriously. So the top level management should put some pressure. They should support this high level quality. They should support this quality in a company at a very high level. Top management must support the quality, maybe at the high level. Okay, so without support at a high level in a company, in an organization, many workers, many employees, they may not take the quality system seriously. Now let's see quickly what are the quality system activities. Okay, what activities are involved in a quality system? Number one, auditing of projects. An organization deals with develops, or they are involved in so many projects. So we have to properly audit the different projects. Another activity is development of standards, procedures, and guidelines. We have to develop the different quality standards, different procedures, and different guidelines, which will be helping in getting a quality system. Next activity is production of reports for the top management. For the top management also, we have to produce some reports which the management may use, the top management may use. So production of reports for the top management. Here we have to summarize the effectiveness of the quality system organization. Okay, we have to summarize what? We have to summarize the effectiveness of quality system in the organization. What is the effectiveness of quality system? What is the use of quality system? That has to be summarized in the organization. And finally, one of the most important activities, review of the quality system itself. So you have developed a quality system, you have to also review it periodically, where you are doing things wrong, whether you are going in correct direction or not, whether you are following correct standards or not, whether you are following correct procedures or not, you have to review. So one of the most important activities, review of the quality system itself. Okay, these are the different activities involved in developing a quality system. And let's say another important activity is that a good quality system must be well documented. If you are developing a quality system, it has to be well documented, because today you have developed something and tomorrow as a person being you got a good better offer in another organization, you leave, then who will recall those things? So whatever you are following, that has to be properly documented. A good quality system must be well documented. Without a properly documented quality system, application of quality procedures become ad hoc. So if you don't document those what procedures or these standards, etc., without a properly documented quality system, whatever you're applying, that become ad hoc. Application of quality procedures, they become ad hoc. Then, since it will become ad hoc, what result you will get? It may lead to which kind of result? It may result in large variations in the quality of the product delivered. So, since you are not documenting, the application of quality procedures become ad hoc, and it results in large variations. Where it results in large variations in the quality of the products delivered. Okay. Further, it has some other problems. An undocumented quality system sends clear messages to the staff about the attitude of the organization towards quality assurance. So, if you are not documenting your procedure, your standards, your system, an undocumented quality system, it will send clear messages to the different staff members, to the workers, about the attitude of the organizations towards achieving quality assurance. That means they will feel that, okay, whatever haphazardly we can do, because these people are not worried about the quality. So this message, this attitude of the organization will be passed to the employees, to the staff members of the organizations towards achieving quality assurance. International standards such as ISO 9000 provide guidance on how to organize the quality system. So I have already told you ISO 9000 is what standard? These are international standard. So international standards such as ISO 9000, they provide different guidance. Okay, they provide some guidance on how to organize a quality system, how you can organize a quality system. So this ISO 9000, etc., these international standards, they provide guidance. Now let's say the evolution of quality systems, how the quality systems are evolved. Very much important, please carefully listen. Quality systems have evolved over the last 6 decades. So normally these quality systems, they have evolved over the last 6 or last 7 decades. Prior to World War II, okay, prior to Second World War, it is the accepted way to produce quality products. How? Prior to World War II, Second World War, people have followed some ways to find out how to develop quality products. What are the ways? These two things. Inspect the finished products, eliminate defective products. So prior to World War II, Second World War, the people, how they are producing quality products, they are first inspecting the finished products, the finished outputs of the finished products. Then after inspecting that, definitely you will get some good products or some defective products. They are simply eliminating or throwing the defective products. Whatever was left out, those are the what they were thinking they are the quality products. So this was happening when? Prior to World War II. So prior to Second World War, how people are getting good quality products? They were inspecting the finished products, and then what were defective products out of all those finished products, they were removing the defective products, and whatever was remaining, they were treating that, okay, these remaining products are quality products. This was happening before this Second World War. Now, after World War II, okay, since Second World War, quality systems of organizations have undergone 4 stages of evolution. Then a massive change occurred. After World War II, these quality systems of organizations, they have undergone sea change. It has undergone major changes. So how many? So 4 stages of evolution they have come across. Since World War II, quality systems of organizations have undergone 4 stages of evolution. Let's see what are the 4 stages of evolution if time will permit. So after this, in World War II, many advances they came from the Japanese. This helped resurrect Japanese economy. As here we have seen that after World War, the quality systems of organizations have undergone 4 stages of evolution. Let's see what are the 4 stages of evolution. Number 1, inspection. Number 2, quality control. Number 3, quality assurance. Then PQA. So it has gone through 4 levels. Okay, it has gone through 4 stages of evolution. Let's see: inspection, quality control, quality assurance, and total quality management. So if we'll see the inspection, this was when it was happening. Before this World War II, people are inspecting the finished products, that is inspection. Then these 3 things came: quality control, quality assurance, and total quality management. So initially, inspection means you are inspecting the product. You are not giving emphasis on the process or the methodology or the procedure you are following. You are only inspecting the product. So that's why it is a product-oriented quality system. It is product-oriented quality assurance. Gradually, people felt that, oh, if we can give emphasis on the process, the methodology, the procedure, then if that is a good process, if you are using a good process, then it is bound that whatever product you will get, that will be of good quality. Please say how the motivation comes from. People during the inspection stage, they were inspecting only the finished product. Then they are removing the defective products. Whatever left, they were thinking that this is the best quality product. But now, then gradually they thought, why you look at the product? If we can look at the process, the methodology we have used, the procedure we have used, and if that will be a good quality process or procedure or what you can say methodology, then by applying that process or methodology or this what activity, obviously what product you will get, that will be bound to a quality product. So that's why there is a migration from product to assurance to process assurance. People we are migrating, moving from, or they are initially giving emphasis on product. If the process you are following is of good quality, obviously what the product you will get, that will be of good quality. This is the assumption. So this is the evolution of quality systems. Initially, during World War II, people are using inspection process. Then gradually they have moved to quality control, then quality assurance, and then total quality management. TQM, very, very important. And let's see in future what is that. Okay. So this I have already told you. The initial product inspection method gave way to quality control. This I have already told you. Inspection, we are inspecting the finished good, removing the defective ones, whatever you have that was remained, that is the what quality product. Good ones will represent the quality products. Okay, good ones will represent the quality products. So from this inspection, it has gave birth to quality control. Initial product inspection method, it gave way to quality control. Let's see in quality control what we are doing. In quality control, not only detect determine the causes behind the defects. So in inspection, we are finding out, we are detecting the defective products and removing them, eliminate them. In quality control, we are also identifying or detecting the defective products and eliminate them. Additionally, we are also determining the causes behind the defects. What are the reasons why some of the products were defective? You have to analyze the causes. In quality control, you simply not only you are detecting the defective products and eliminating them, but also You have to determine what are the causes, what are the reasons behind getting these defects. If you can eliminate those causes, obviously the output what you will get, that will be good quality. This is the meaning of quality control. Now let's see the next evolution. Okay, before going to the next, that is quality assurance. Next evolution is quality assurance. Before going to quality assurance, let's first discuss about quality control a little bit more. So what quality control aims at? Quality control aims at correcting the causes of errors. I already told you, not only inspect the defective products, but also not only defect the finished products and identify the defective products, but also you have to identify the cause of the errors. What are the reasons? Quality control aims at correcting the causes of the errors. Identify why this error has occurred, what is the reason, then you try to correct it. Okay? Quality control aims at correcting the causes of errors, not just rejecting the defective products. So statistical quality control, it's a special kind of quality control. Here, the quality of the output of the process is inferred using some statistical method. So here, as its name suggests, statistical quality control. So here, the quality of the output of the process, how it is inferred, how it is determined, how it is inferred. It is inferred by using some statistical methods or some statistical techniques instead of inspection or retesting all products. See, if you are developing only 100 products, okay, you can inspect or test all those 100. But if you are producing lakhs, 10 lakhs or millions of products, it's very much difficult to inspect or test all the products. So that's why you can use some statistical technique, take some samples, take some random samples and inspect up, or instead of inspecting or testing all the products, you just inspect or test that sample of products using some statistical methods, using some statistical techniques. So this is a special technique. Statistical quality control is a special quality control method. Okay, so statistical quality control, or SQC, is a special type of quality control method where the quality of the output of the process is inferred using some statistical methods instead of inspecting or testing of all the products. Okay. So after quality control, what does it came? Quality assurance. The next breakthrough is development of quality assurance principles. Let's see a little bit about quality assurance. So in quality assurance, the basic assumption, the basic premise of modern quality assurance, okay, quality assurance, it is the basic premise of, okay, it is the basic premise of modern quality assurance. So what is the basic premise? What is the basic assumption in case of quality assurance? It says that if an organization's processes are good and they are followed rigorously, then the products are bound to be of good quality. Just I was saying before a few minutes. If the processes that you are following are good and you are following them rigorously, then obviously what products you will get at the end, obviously the products will be of good quality. Okay. So the basic premise, so in quality assurance, the basic premise of modern quality assurance says that if an organization's processes are good and they are followed rigorously, then the products are bound to be of good quality. Okay. All modern quality paradigms, they include what? Let's see. What do the modern quality paradigms include? Modern quality paradigms include guidance for recognizing, defining, analyzing, and improving the production process. So now you see the importance is in the process, the production process. So all the modern quality paradigms include guidance for what? Guidance for recognizing the process. First you have to recognize the process, you have to recognize the good process, then you have to define that process, then you analyze the process, what is doing, what are the plus points, what are the minus points, analyze them. After identifying the plus points and the minus points, then what are the negative, what are the weaknesses or limitations of those processes, then you have to try to improve them. You have to improve the production process. So all modern quality paradigms includes these steps. And next, after this quality assurance, next breakthrough is, okay, next what evolution is total quality management, or TQM. So TQM advocates what? TQM advocates continuous process improvements through process measurements. So now here in quality assurance, I have told that we have to identify the process and we have to try to improve the process. But in TQM, it advocates continuous process improvements. Continuously, we have to improve the processes that we are following. How? Through process measurements. We'll measure the process, various parameters of the process. Then we have to try to, because unless we'll measure the process parameters, how can improve it? So we have to measure the process, different parameters using different metrics. Then we should try to improve the processes. How? So continuously. We can continuously improve the processes. That's what TQM advocates. So TQM, total quality management, it advocates how to continuously improve the processes through various process measurements. Okay, that's what is the objective of TQM. So TQM advocates continuous process improvements through process measurements. Okay. So this another important term associated with the TQM is business process reengineering. Shortly we call it BPR. So BPR, it is a term related to total quality management. The process reengineering goes a step further than quality assurance. So in BPR or business process reengineering, the process reengineering, what processes you are using? I already told you, if the process you are using, it is of good quality, obviously then the final product will be of good quality. So in business process reengineering or BPR, the process reengineering goes a step ahead, a step further than quality assurance. It aims at continuous process improvement. Okay. So BPR, it aims at continuous process improvement. How continuously you can improve the process. TQM focuses on re-engineering of the software process. So I hope in software engineering you must have studied software engineering, software reverse engineering, or software re-engineering. If it is not taught, you please read yourself what is software re-engineering and reverse engineering. Reverse engineering, forward engineering, no. You start from SRS document, prepare the SRS document, then design, then what coding, then testing, like that. Reverse engineering means you have to go in the backward direction. Like a product is there where only code is there, not other any SRS document design is not, documents are not there. So you have to move backward. That means from code you have to get the design document. From design you have to go to the SRS document, so that when any change is required, you can start from correcting the requirements. This is called as reverse engineering. And for this forward engineering, that means first requirement analysis, then coding, design, then coding, then testing, followed by the reverse engineering. That means first what from the coding you get the design documents, from design documents you go to the, you get the SRS document. So this is the what reverse engineering. So software, this forward engineering plus this reverse engineering, it will give you software re-engineering. The details are there in any book, maybe in Rajim book you can see. Please have a look at that. So this TQM, it focuses on re-engineering of the software processes. That means forward engineering as well as reverse engineering. TQM focuses on re-engineering of software processes. Any organization, not just with the software development. I am repeating again the difference between BPR and TQM. TQM focuses on only the re-engineering of the software process, but whereas BPR aims at re-engineering the way the business is carried out in any organization, not just the software development. This is the difference between business process re-engineering and total quality management. So now TQM goes beyond documenting the process, not only just the documents, it does that, but it goes beyond that. TQM goes beyond documenting processes. It optimizes them through redesign, total quality management. It optimizes the document process through redesign. Over the years, the quality paradigm has shifted from product assurance to process assurance. Previously, during World War II, etc., people are giving emphasis on only the products. They are inspecting the finished products. But nowadays, people are giving emphasis on the process because they know if the process is of good quality and it is followed very rigorously, then obviously the final product will or it bound to be of good quality. So over the years, the quality paradigm has shifted from what to what? From product assurance to process assurance. Okay. Now let's see how can improve the processes. Process improvement implies introducing process changes to improve product quality, reduce cost, and accelerate schedules. Okay. Process improvement, it implies introducing what? Process changes. Why? To improve the quality of the product or product quality, to reduce the different costs, and to accelerate the different schedules. How the different schedules can be accelerated so the process can be finished quickly and the product can be obtained as per the schedule, or even if earlier than the schedule, earlier than the prescribed schedule. Most process improvement work so far has focused on defect reduction. So far, most of the process improvement work, they have focused on only defect reduction. Okay, they have focused on defect reduction. These are some of the process attributes, like what are the process characteristics and the description, because now we are giving emphasis on the process. If the process is of good quality, you are following the process rigorously, then obviously the final product will be of good quality. These are some of the process characteristics and a brief description is given. We are running out of time. These are easy things you can read yourself. Like understandable means to what extent is the process explicitly defined and how easy it to understand the process definition. That means how easily you can understand the process definition. Similarly, other things are easy. You read yourself. These are very common terms: visibility, supportability, acceptability, reliability. How far your process is robustness, maintainability, rapidity, etc. These are easy things. You just see yourself. We'll skip those things. And this is the process improvement cycle. How the process can be improved. I have already told you the process can be improved if you can measure it using some metrics. If you cannot measure it, then you cannot improve it. So first you have to measure the process using some parameters or using some metrics. Then you analyze whether it is of what is its limit, whether it is below the desired value or above the desired value. Analyze them and analyze the advantages and disadvantages of the process. Then you have to change the process. If it is not up to the mark, what are the disadvantages? Find out the reasons of the disadvantages and then change the process. And after changing the process, again measure whether the metrics you have computed earlier, whether there is any improvement or not. Improvement, okay. If not improvement, again analyze and change. In this way, it will follow a cycle till you get the values those are desirable according to your satisfaction. Then you can stop this process. Otherwise, you go on analyzing and changing. Every time you measure the performance, if the performance is satisfactory, then you can stop. This is how you can improve the process. This is the process improvement cycle. Okay. Process improvement stages, I have already told you 3 stages are there. You have to first measure, then analyze and change. Those things I have already told here. Process measurement means first the attributes of the process, the existing process are measured. It will form the baseline. It will form a baseline for assessing improvements. Then you analyze the process is assessed, the process is evaluated, and the bottlenecks and weaknesses are identified. And then you change, process change. You have to change the process. Changes to the process that have been identified during the analysis are introduced. During the analysis, you have identified these are the bottlenecks and weakness. Then you have to remove the bottlenecks and weakness. You have to change the bottlenecks and weakness. This is in process change. Changes to the process that have been identified during the analysis phase. Okay, they are introduced. So process change means changes to the process that have been identified during the analysis stage are introduced. Okay. So we'll see about the process and product quality. I have already told you that A good process is usually required to produce a good product. If you are using a good process, obviously the final output will be a good quality. So that's why a good process is usually required to produce a good product. For manufactured goods, process is the principal quality determinant. Okay, so if you are manufacturing some goods, for manufactured goods, process is the principal quality determinant. If your process is a very poor process, very ill-defined process, obviously your final product will be very poor. It will be bad quality. So if your process is of good quality, obviously the final product will be of good quality. So for manufactured goods, process is the principal quality determinant. For design-based activity, other factors are also involved. Okay, if you are developing something which is totally based on the design, for design-based activity, other factors are also involved. For example, the capability of the designers, how your designers are capable, how they are efficient. Based on that, it will depend on, it will affect the quality of the final product or the output. Today we have discussed some basic concepts of quality systems. We have explained the quality factors associated with the software product. Then we have discussed the evolution of quality systems. I have told first it was started with inspection, then quality control. Next evolution is quality assurance, and the next evolution is TQM, total quality management. We have also explained the process improvement cycle. This is how we have seen the basic concept of quality. Now let's quickly see at least one, that is ISO. This is one of the important standard, ISO 9000 series. Let's discuss on half an hour on this ISO 9000 series regarding the quality aspects. Okay. If you require break, we can give 5 minutes break. Otherwise, you can continue for half an hour. Yes, if required, you can take 5 minutes break. Continue.
Sir, you are muted, sir. Please unmute yourself.
So now is it audible? Yes.
Yes, sir.
So I hope now it is audible. Now we'll process. Okay. So as I have already told you, ISO 9000 is applicable to organizations which are engaged in design, development, production, and servicing of goods. It is applicable to both software development organizations. So now we'll see our software companies or software development organizations. So ISO 9000 is applicable to most of the software development organizations. Let's see ISO 9002. It is applicable to what? ISO 9002. It applies to organizations who do not design products, but are only involved in what production. So ISO 9002 is applicable to those organizations who do not design the products, but they are only involved in productions. Let's see some examples. Examples of this category of industries include what? Steel or car manufacturing industries. So these steel or car manufacturing industries, they buy the product and plant designs from external resources. The design they buy from some other countries, and what do? They only manufacture the products. You see the Honda cars, they are not just produced in the designed in the India. They purchase this they purchase this design from outside, and only they manufacture the cars in India. So the steel or car manufacturing industries, they, for them ISO 9000 is applicable. Now it is obvious that it is not applicable to software development organizations, because here we cannot design from outside and we purchase this thing. So ISO 9002 cannot be applicable to software development organizations. ISO 9003, it is applicable to organizations involved only in installation and testing of the products. So the organizations which are involved in installation and testing of the products, they are, for them ISO 9003 is applicable. You know, suppose that generator, it is developed by somebody else, but they are giving to some third parties. Those, they will go and install the generators and test them there at the client side. For those kinds of organizations, ISO 9003 is applicable. Now let's see ISO 9000 for software industries. Which standard will be applicable? Whether all the clauses will be applicable or not, let's quickly see. ISO 9000 is a generic standard. It's applicable to many industries, starting from a steel manufacturing industry to a service rendering company. But the problem is that now many clauses of ISO 9000 documents, they use generic terminologies applicable to many organizations, many types of many categories of organizations. It is very difficult to interpret them in the context of software organizations. There are so many generic terminologies. It is very difficult to interpret the clauses of ISO 9000. It is more difficult to interpret them in the context of software organizations. Let's see how software organization is different than other industries. It is very difficult to interpret many clauses for software industry. As I have already told you, the ISO 9000 series, it contains many generic terminologies. It is very difficult to interpret those generic terminologies in the context of software organizations. Let's see some of the differences. It is very difficult to interpret many clauses for software industry. Software development is radically different from development of other products. Isn't it that you will be definitely agreed that software development is radically different from development of other kinds of products? Examples, you know. Now, software is intangible. You cannot visualize it. It's not tangible. Software is intangible. Therefore, it is difficult to control. It is difficult to control. Okay, it is very much difficult to control anything that we cannot see and feel, isn't it? Which you cannot see and feel, it is very much difficult to control. So we have known that software is intangible. It is not tangible. Therefore, it is difficult to control. It is difficult to control as isn't it? Therefore, it is difficult to control. It is difficult to control anything else, any product, anything or anything, okay, or any product that we cannot see and feel. In contrast, let's say some hardware products in a car manufacturing unit, you can see the product being developed through stages such as fitting some engine, fitting doors, etc. What is the stage right now? So right now only chassis is built. Then we can see that doors have been fitted, engines have been fitted. We can easily mark this progress. So it can see what is the progress till now. We can if we can see the progress, then we can control it. One can accurately tell about the status of the product, status of the car development at any point of time. But software project management is an altogether different ball game, since we cannot visualize, we cannot see, we cannot say in which stage that software product is in. During software development, the only raw material consumed is what? It's only data. For any other product development, you require lots of materials, raw materials, lot of raw materials consumed. For example, in steel industry, it consumes large volumes of iron ore, coal, limestone, etc. So we can see there's a difference between the software industries and the other industries. ISO 9000 standards have many clauses corresponding to the raw material control. Since I have already told you, in ISO 9000, several clauses are generic, like for some development organizations or some hardware organizations like this. In ISO 9000 standards have many clauses corresponding to raw material control. It is not relevant to software organizations. So those raw material control clauses, they are not relevant to software organizations. They may be relevant to manufacturing organizations, but they are not relevant to software organizations. So that's why the software industries, they are radically different than the other industries. So radical differences exist between software and other product development. So it is very much difficult to interpret various clauses of the original ISO standard in the context of software industry. It is quite difficult. It is very much difficult to interpret various clauses of the original ISO standard in the context of software industry. So that's why what happened, ISO 9000, they had developed a special part which will be relevant for software industries. ISO released a separate document called ISO 9000 Part 3 in 1991. Why? To help interpret ISO standards for software industry. So in order to be applicable to software industries, ISO released a separate document with different clauses called as ISO 9000 Part 3 in 1991, which will be especially helpful for interpreting the ISO standard for software industries. At present, official guidance is inadequate, but at present, the official guidance for software industries is inadequate. I get ISO 9000 certificate now. Let's see why the companies, they are interested to get ISO 9000 certification. Again, very easy. It's a kind of things you can read yourself. Several benefits are there, like confidence of customers in an organization increases. If you are having ISO 9000 certificate, then on your organization, the confidence of customers will be increasing. So there are several benefits. If you are having ISO 9000 certification, confidence of customers in an organization, it increases. If organization qualified for ISO 9000 certification, okay. So confidence of customers in an organization increases if the organization is qualified. It is qualified for ISO 9000 certification. This is especially very much true in the international market. So that's why several organizations, they try to get ISO 9000 certificate. Many international software development contracts insist development organization to have ISO 9000 certification. When you are participating in tendering process, many international software development contracts, while you want to get some contract, they insist that, do you have ISO 9000 certification? If no, you cannot participate in the tendering process. So that's why many organizations, they are interested to get ISO 9000 certification. So then we'll say, since many international software development contracts, they insist the development organizations should have ISO 9000 certification. This requires a well-documented software production process to be in place. Now, if you are having ISO 9000 certification, in order to get ISO 9000 certification, it is required that it requires a well-documented software production process to be in place. That means you are having a well-documented software production process in place. Then this will automatically contribute to repeatable and higher quality software. So if you are having a well-documented software production process in place, then it contributes to repeatable and higher quality software. Your quality of software is good and it will repeatable. That means by applying the same process, you can again and again get good quality software products here. It makes development process focused, efficient, and cost effective. If you are having this ISO 9000 certification, then your processes are obviously, they will be of good quality processes. This makes development process focused, efficient, and cost effective. If you are having the ISO 9000 certification process, it points out the weakness of an organization. Hence, it recommends the remedial actions that you should take to improve the quality of your product in your organization. ISO 9000 certification also sets the basic framework for development of an optimal process and TQM. I have already seen what is the last evolution so far. First is inspection, then quality control, then quality assurance, then TQM. So our ultimate objective should be focused on what? On TQM. So if you are having ISO 9000 certification, it automatically sets the basic framework for development of an optimal process and achieving TQM, total quality management. Now, we have seen why we require to get ISO 9000 certification. Next, let's see quickly how to get ISO 9000 certification. How you can get ISO 9000 certification? What is the procedure? You can, by following which you can get ISO 9000 certification. An organization intending to obtain ISO 9000 certification, it has to first apply to a ISO 9000 register for registration. There are different, every country they are having some ISO 9000 register. You have to first apply to the ISO 9000 register for getting the registration. ISO 9000 registration process consists of several stages. So let's see what are those stages. First stage is application stage. This I have already told you. First, you have to apply to a registrar for registration. Then next stage is pre-assessment. Pre-assessment means what? The registrar makes a rough assessment of the organization. Those who have known NBA accreditation, etc., we are first applying to the NBA for getting accreditation for organization. Then what do they do? You have to give a self-assessment kind of thing, document. Then they will verify, they will make a pre-assessment. Similarly, in ISO 9000, after you are applying to the registrar for registration, the registrar will make a rough assessment of the organization. A rough assessment of the organization. This is known as pre-assessment. Then next step is document review and adequacy audit. Then the registrar will review all the documents that you have submitted and audit for adequacy. So then the registrar will process then you have to process and quality related documents. So let's see what will be reviewed. So during the registration time, you have to review some documents. Then which kind of documents you have to submit? The documents related to your process that you are using and the quality. At the organization or on behalf of the organizations, you have to submit the process and quality related documents to the registrar. Then the registrar will review all those documents. Then after reviewing the documents, he will give some suggestions for improvements. He will make some suggestions for improvements where you are lacking, where some drawback is there, where some lacuna is there, where some limitations are are there, the registrar will make suggestions for improvements in those cases. Then what you have to do after getting those comments, then you have to comply those comments. Compliance audit. The registrar checks whether the suggestions made by it during review have been complied or not, because the registrar has given some comments. Then you have to comply to the comment. He has told, okay, these points are lacking, you have to comply them. These points are the drawbacks. These documents are not submitted, like that. So whatever comments the registrar has given, you have to comply all those comments. This is known as compliance audit. Then comes registration. If the registrar is satisfied, yes, whatever comments you have done, he has given, you have perfectly followed those comments, you have complied accordingly. If the compliance is satisfactory, then you will get a certificate. Now this is known as registration phase. The registrar awards ISO 9000 certificate after successful completions of all previous phases. So if the registrar is satisfied, you have successfully complied all the points, all the comments, then the registrar awards ISO 9000 certificate. Okay. Now the registrar awards ISO 9000 certificate after successful completions of all previous pages. The last phase perhaps is continued surveillance. The registrar continues monitoring the organization periodically. It is not just one, after getting this certificate you will just manipulate. You will not stick to the quality. No, the registrar continues monitoring the organization periodically. Periodically they will have to monitor your process, your products. If sometimes the registrar finds you are not following, you are not sticking to the quality, they may withdraw the certificate that they had given. This is known as an ISO certified organization. Let's see how the certificate can be used, how the organization can use the certificate it has got from the registrar. An ISO certified organization can use the certificate for corporate advertisements only. Please remember, this ISO certification, this organization, it can use the certificate for corporate advertisements only. The organization cannot use the certificates to advertise its products. It cannot use the certificate to advertise its products. ISO 9000 certifies the organization's process, not any product of the organization. Please remember why the organization cannot use the certificate to advertise the products. Because ISO 9000 certifies the organization's process, not any product of the organization. Hence, the organization cannot use the certificate to advertise its products. It can only use the certificate for corporate advertisements. An organization using ISO certificate for product advertisements risks withdrawal of the certificate. If any time the registrar says that the organization is using ISO certificate for product advertisements, then they may withdraw the certificate. There is a risk of withdrawal of the certificate. Okay. Now, I have already told you ISO 9000 had so many requirements, so many clauses. We cannot read all those things. Many clauses. So some important clauses I have saying. Those are there in the book. Please read yourself. Like one clause is management of responsibility. Now we are discussing summary of the ISO 9000 requirements. One clause is management responsibility. It says that management must have an adequate quality policy. Every organization, every management must have an effective quality policy. The responsibility and authority of all those whose work affects quality must be defined and documented. With the product, who are associated, their responsibility and authority must be defined and documented. So management responsibility means the management must have an effective quality policy. The responsibility and authority of all those employees whose work affects the quality of the product, their responsibility and authority must be defined and documented. This is what is meant by management responsibility. It is clause number is 4.1. No need to remember all those clauses. Huge list of clauses are there. You cannot go. For your understanding, I have added few of them. I am skipping those things. You can read yourself. Let's like this. So all documents concerned with the development of a software product should be properly managed, should be properly authorized, and should be properly controlled. Proper plans should be prepared. The progress against these plans also should be monitored. So these are some of the salient features of ISO 9001 requirements. We are discussing the management responsibility. These are all these management responsibilities. Okay. So similarly, important documents that are independently checked and reviewed for the effectiveness and correctness. The products should also be tested against the specifications as mentioned in the SRS document. Several organizational aspects are there, like management aspects, management reporting of the quality team. These are some of the salient features of ISO 9000 requirements. See, I had given only one clause. Many other clauses are there in the book, you can see, but no need to remember those clauses. Now let's quickly look at what are the shortcomings of ISO 9001 certification. We have seen so many advantages of ISO 9001 certification. Let's quickly look at the shortcomings of ISO 9001 certification. ISO 9000 requires a product process to be adhered to, but does not guarantee the process to be of high quality. Please see, ISO 9000 requires what? A production process to be adhered to, a good production process to be adhered to. But it does not guarantee the process to be of high quality. ISO 9001 certification also does not give any guidance for defining an appropriate process. What is an appropriate process? ISO 9000 does not give any guideline for defining an appropriate process. Similarly, ISO 9000 certification process, it is not foolproof. No international accreditation agency exists. Also, there is more likely variations in the norms of awarding certificates among different accreditation agencies and among the registrars. Some of the registrars are very strict. Some of the registrars are very lenient. For example, if you see ISO 9000 from USA, very difficult, but getting ISO 9000 from India, from Calcutta, very easy. So that's why there is likely variations in the norms of awarding certificates. Among what? There is likely variations in terms of awarding certificates among different accreditation agencies and among the registrars. That's why in some countries getting the ISO certification is very difficult, like USA, etc. Whereas getting this ISO certification may be easy in some of the countries because the registrars are lenient. Organizations qualifying for ISO 9001 certification, they tend to downplay the domain expertise. They tend to believe that since a good process is in place, so any engineer is as effective as any other engineer in doing any particular activity relating to software development. They think that since a good process is in place, so obviously the product is good, and any engineer, it is as good as, okay, any engineer in doing any particular activity relating to software development is as effective as any other engineer, which is not true. Every engineer, it is having different skills, different experience, their effectiveness is different, but they are thinking that, since we are having ISO 9001 certification, we are having a good process, so all the engineers are of effective, they are of they are of same calibrity, they are having same experience, their efficiency is same, which is not practically true. Another shortcoming is that in manufacturing industry, there is a clear link between the process quality and the product quality, and hence once a process is calibrated, it can be run again and again, which will lead to producing quality goods. But in software development, this may not happen. Software development is a creative process. Here, individual skills and experience is significant. It matters. Individual skills and experience is significant. Individual skills and experience matter in getting a good software. So this concept in case of manufacturing industries, which says that once a process is calibrated, can be run again and again producing quality goods, may not be true in case of software product. It may not be applicable. It may not be good in case of software products. Many areas of software development are very specialized. So special expertise and experience or domain expertise, they are required. ISO 9000 does not automatically lead to continuous process improvement. This is the most important difficulty. That ISO 9001 does not automatically lead to continuous process improvement. It does not automatically lead to TQM. Okay, this is most drawback, because we aim at TQM. ISO 9001 certification does not automatically lead to total quality management. So similarly, other some shortcomings are there. These are easy, you can read yourself. ISO 9000 addresses mostly the management aspects only. The techniques specific to software development have been ignored in ISO 9001 certification. Okay. Now, ISO 9000 certification? ISO 9000 addresses mostly management aspects. Okay. Now, ISO 9001 addresses mostly management aspects. The techniques which are specific to software development have been ignored in ISO 9000 certification. What are the techniques specific to software development, such as confusion management, reviews? We have seen different reviews, release builds, or release management, problem notification system, intranets, etc. Many such types of techniques which are specific to software development, they are ignored in ISO 9001 certification. These are some of the drawbacks of ISO 9001 certification. Today I have discussed ISO 9000 standard. So we have seen three important standards of ISO 9000 series. They are ISO 9001, 9002, 9003. We have seen that for software organizations, ISO 9001 is applicable. ISO 9002 and 9003, they are not applicable to software industries. We have discussed the requirements for ISO. We have also discussed how an organization can get ISO 9000 certification. We have also discussed the limitations of ISO 9000 certification. This is something about ISO 9000 standard. This is something about ISO 9000 standard. Okay, basically we have taken from this software project management book and the software engineering book. Thank you very much for your patientful hearing. I will come to any questions, please. Basically, today we have seen the quality system, and one particular standard we have taken ISO 9001. So next class we'll try to take another standard, that is SCI-CMM, Software Engineering Institute Capability Maturity Model. So now, any doubt? Let's quickly look at. Any doubt, please? Please ask.